Welcome back. In this video, what we're going to do is we're going to find derivatives. We're going to have more techniques of finding derivatives. We're going to add in some product rule, some quotient rule, and some reciprocal rule to our basic rules that we already have, and our shortcuts, and keep on building on these concepts. This first part is just formalizing some of the stuff that we've already done. So our derivative of a constant 0, derivative of a line is the slope of that line, the derivative using power rule. If we have a constant, pull that constant out front. If we have a polynomial function, take the derivative of each one individually. One of the new rules, take that back. Let me do an example of that first and take a derivative of the polynomial function. So f prime of x using our power rule is going to be 8x cubed minus 15x squared minus 4. One of our new rules is our product rule. When we have a couple of functions multiplied together, to find the derivative of two things that are multiplied together is the derivative of the first function times the second function plus the derivative of the second function times the first function. For this one, in this assignment, you might be able to simplify this. Like I could multiply this out, but as we go deeper in and we get more different functions that we're looking at, you won't be able to algebraically simplify it, so you've got to use our product rule. So in this particular example, if I find y prime is going to be 2, which is the derivative of that 2x minus 3, times x squared minus x plus 4. And then the derivative of the second part is going to be 2x minus 1. We got to multiply that by 2x minus 3. Now it just becomes algebra. Now we just need to multiply everything out. So when I do this, it's y prime is 2x squared minus 2x plus 8. When I FOIL this part out, it's going to be 4x squared minus 6x minus 2x plus 3. I combine all my like terms. My derivative is going to be 6x squared minus 10x plus 11. Like I was saying a moment ago, sometimes you can simplify this algebraically in this first section, but as we get deeper into more different derivatives, more different functions, you won't be able to simplify it algebraically. Our second new rule is our quotient rule. If you have a quotient, I want to take the derivative. It's the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. So in my particular example, this one order is important because of the minus. In the product rule, the order is not important because you're adding them. But in this one, the derivative of the top is 2, and it's times 4 minus x. And then minus the derivative of the bottom is negative 1, and that's times 2x minus 3. And then it's over 4 minus x, quantity squared. When I simplify that, these minuses will drop out. And so then I just get, this is going to be 8 minus 3, which is 5. And then it's going to be minus 2x plus 2x, which is going to go away. And that's going to be over the 4 minus x quantity squared. Our third new rule is what we call a reciprocal rule. This one you don't have to know necessarily memorize. You can always use quotient rule. But if you remember reciprocal rule, it's a little bit easier because it's just the second half of quotient rule. It's minus the derivative of the denominator over the denominator squared. In this particular example that I did, I have a 2 on top. I just put something other than a 1 there. That's when you do this, that you would pull that 2 out front. So y prime is going to be negative 2 times 2x over x squared plus 1 squared, or negative 4x over x squared plus 1 quantity squared. Reciprocal rule can be a really convenient tool to use. You don't have to know it, but it is really helpful sometimes to know it. One of the things I will do to you, I'll give you some problems like this where I give you a chart of values for when x is a certain value and f of x and f prime of x, g prime of x. And then I'll define different equations based upon that. And when I do this to you, I'm looking specifically, do you know the rules of these rules that we've been working with? So like for instance in this first one where h of x is 2 times f of x and I want you to find a derivative at 1, h prime of 1 is going to be 2 times f prime of 1. And f prime of 1 then in my chart is negative 1. So it's 2 times negative 1 or negative 2. when I define something like in my second one where I have r of x equals g of x times f of x, now when I go to find the derivative of r at 2, it's going to be the derivative of the first function, so it's going to be g prime at 2 times f of 2, and then plus f prime at 2 times g of 2. From here, you're going to plug in all of those values. So I think this was 3. This is negative 3. You get these values from that chart. And then plus 1 times 2. And I ended up, when I simplify it, getting negative 7. I'm not telling you what the function f is or what the function g is. I'm just telling you about the original function and about the derivative. Let's do 3 down here. In 3, if I wanted to find k prime of 4, k prime of 4 is going to be f prime of 4 times g of 4 minus g prime of 4 times f of 4 over f of 4. I'm lying, g of 4. Over the denominator squared, so g of 4 squared. When I filled in those values, I got negative 2 times 1 minus negative 3 times 4 over 1 squared, or 10. And then finally, that last one is an example of the reciprocal rule. When I take that derivative, w prime of 3 would be negative 2 times f prime of 3 over f of 3 squared. So in my example, I ended up, when I put in there, I get 3 and 2 on top. So it's negative 2 times 3 over 2 squared, which I got to be negative 3/2. This is a way we can ask those questions about reciprocal rule and quotient rule and chain rule. It's not chain rule, sorry, product rule, without letting you simplify the equations. All right, keep on building on this derivatives.